Okay, so here's the question. So the question says, this is the a quadratic equation stuff. Maybe you have never done quadratic equation, have you? Or
Yeah, I have.
you have, okay, sure. So the question says that h is given by negative 4.9 squared plus 25t. So what is this all about? It says, I'm going to zoom in a little bit. The equation above expresses the appropriate height in meters of a ball t seconds after it is launched vertically upward from the ground with an initial velocity of 25. After approximately how many seconds will the ball hit the ground? Okay. So there's a ball, and this was launched, and it goes up and then comes back down, right? So that's sort of a projectile motion.
Yeah.
And we want to know, basically what it's asking is, how many seconds will the, how many seconds, that's what they're asking, right?
Yeah.
So what is t when it hits the ground? Okay, so in order to figure out t, we need to know what?
H.
We need to know h. So we need to plug in h, some value for h.
Yeah.
So what should we plug in there?
One of the
So I'll give you some clue,
oh
right? Let's say time is 0, okay?
yeah.
When you plug in time equals 0 there, what do you get for h?
0.
0. Let's plug in 1. So 1, 1 there. What do you get?
Minus.
Yeah, so this is a calculator allow section.
Okay.
But that'll be negative 4.9 plus 25, isn't it?
Yeah.
Then you get this one, 20.1.
Mm-hmm.
So height for that is 20.1.
Mm-hmm.
And we can keep doing it. Let's plug in 3.5 because it says 3.5, right?
Yeah.
We can plug in 4. We can plug in 4.5. We can plug in 5 there. However, this is going to take a long time, right?
Yeah.
But anyway, we can just try, just for the sake of explanation.
Sure.
Because you're first bit not so familiar with the quadratic equation, I guess. So 3.5 squared. So 4.9 times by 3.5 squared plus 25 times by 3.5.
Mm-hmm.
So it'll be 27.475. That means 3.5 seconds later, height will be about 27. So t equals to 1 will be around here. T equals to 3.5. I think it'll be around there.
Mm-hmm.
Let's plug in 4. So we got negative 4.9 answer square, and then plus 25 times by answer. Answer is 4. And that gives you 21.7, 21.6. And as you can see, it's falling, right? So
Yeah.
going over here. Okay.
Wait, sorry. How do you know that it's falling at 4.5?
Oh, because it went to 27.
Yeah.
And then it's 21.6 for
Right. Yeah.
So I'm not actually sure, whether t equals to 3.5 occurs while this is going up or while this is going down. So I don't actually have any information whether this one is like there or there or there, okay?
Yeah.
All I know is this is somewhere there. And t equals to 4 is lower than 27.
Right.
So definitely this one must be on its way down.
Yeah.
Yeah, so this is on its way up, pretty sure, because right after this is still up, right?
Yeah.
But right after that, it's down. So that's definitely falling down. But as for this one, I'm not sure whether this is happening while this is going up or going down.
Yeah.
But that's not really important. So if I plug in 4.5 there, so negative 4.9 times by 4.5 squared minus plus 25t. Still falling. It's about 13. Finally, if I plug in 5, plus 25 times by 5, so it is 2.5.
Yep.
So can you answer this question now, please?
It's probably the 5, the D.
That's right, D.
Yep.
So is there a quicker way of solving this? Yes.
I
All
would
you need
assume
to do is just let that equal to 0. We
so.
want to
Oh,
find
okay.
when the height equals
Yeah.
0. So it goes like this. 0 equals to negative 4.9t plus 25t square. This is square here, right?
Yeah.
Now, if I give you some question like 0 equals to negative 4.9t plus 2, you can solve that, right?
Yeah.
That's a linear equation. I want you to try
Yeah.
that for a couple of seconds. I just need to go get some water, okay?
Sure.
Be right back. Have you tried this one?
Yes. 4 point.
So if you move this one over there, you get 4.9t equals to 2, so t equals to 2 over 4.9, right?
Yeah.
So if you have quadratic equation, so there are a number of ways of solving quadratic equation, but this type here is really easy because, like, you know, general equation for quadratic equation is y equals to ax squared. So there's a square term, there is a linear term, and then there is constant.
Mm-hmm.
Now, when the constant term is missing, that's like this one here, okay? There's t squared and t, right? Then it's really easy to factorize. And it goes like this. This is negative 4.9 t. Sorry. You just pull out, you just factorize t, and then you make a bracket, negative 4.9 t plus 25.
All right. Yeah.
So let me give you another question. If you have a 0 equals to x minus 2, x minus 3, what's the value of x?
Wait, in like.
So if you have this equation,
Yeah.
you can just you can just guess, okay? So what is the value of x which satisfies this equation?
Oh, 0.
So if I plug in x equals 0 there,
Oh, wait, no.
0, 0, then it's actually negative 2 times 1, negative 3, which is equal to negative 6, which is not 0.
I'm not sure if it's if it
Okay.
has to be constant.
The answer is 2 or 3.
Oh, okay, right.
If I tell you something, like I'm going to give you another example, okay? So 0 equals to a times by b.
Mm-hmm.
That means either a is 0 or b is 0. Is that right?
Yeah.
If I give you, because 0 times by b is 0, and a times by 0 is 0 as well.
Yeah.
If I give you 0 equals to x minus 2, x minus 3, then either this is 0 or that is 0. Is that right?
Yes.
Because it's that one times by that one. So if x minus 2 is 0, then x minus 2 is 0, then x is equal to 2. Is that right?
Yeah.
If I have x minus 3 equals 0, then x minus 3 equals 0, then you get x is equal to 3. Is that right?
Yeah.
Yeah. So that's why you get this answer here.
Yeah. Okay.
Now, if I give you 0 equals to t and then x and then t minus 2, then what's the value of t? What are the values of t that satisfies this equation?
2
or
um
so if you have that, either that must be 0 or that must be 0.
so 2 or 0.
2 or 0, that's right. Because that is 0 or
Yeah.
that's 0, right? Because if
Mm-hmm.
that's 0, then t must be 2.
Yeah.
Understand? Yeah. So you get yeah, you get that. And yeah, so let's have a look at this one now. Then you can see that t is 0 or that stuff is 0, isn't it?
Yeah.
So if you solve this, 4.9t, you move that over there, and 4.9t equals to 25, and t equals to 25 over 4.9. So you can find exactly, so 25 over 4.9 is 5.1.
Yeah.
And that's how you solve this question. So it's very close to 5, isn't it?
Yeah. Yeah. Okay.
You can see that when time was 0, height was 0, isn't it? That's supported by that answer here.
Yeah.
And we also find that when t equals to 5.1, height is also 0.
Yeah. Yeah. Okay.
So there are two cases where the height equals 0. That's when it was launched initially, and 5.1 seconds later.
Yeah.
Okay. Now we're going to move on to the next question. So last time we did circle as well, but I'm going to send you a video for that because we already did it.
Yeah.
I'm going to move on to this question 24, 25. Did we do that? Yeah, let's actually do 22 to 20, 22, 23, okay?
Yeah.
I gave that as homework, but we didn't go through it. Okay.
Oh no, actually I did these, but I was kind of unsure if I did it right.
Okay, let's go through it together then.
Yeah.
So you have an annual budget for different programs in Kansas, 2007 to 2010. So these are different programs year. So these are money spent on these different programs in different years. Table above lists annual budget, thousands of dollars. That means you need to put how many zeros after this?
3.
3 more zeros, that's right. 6 different states. State programs in Kansas. So there's only one state, and there are 6 different state programs.
Yeah.
Which one of the following best approximates the average rate of change in the annual budget for agriculture natural resources? This one here. From 2008 to 2010. So 2008 to 2010. Okay. Well, we just have to, all you have to do is that one minus that one, divide by 2.
Yeah.
So of course you can.
Why do you divide by 2? Sorry.
Okay. So there are 2 ways of doing it, okay? You do 485,807 minus 358,708, okay? That's the change from 2008 to 2009, true? That's the annual, the rate of change. Yeah. And you can also do 488,106 minus 485,807. So there isn't much change here, right? There is a lot of change here.
Yeah.
So you can do 485,807 minus 358,708. So 127,099. 127,099. Like that. And then 488,106 minus 485,807, right? So there's only $2,299, right?
Yeah.
So that much change happened on the first year, and that much change happened on the second year. But we're talking about the average.
Yeah.
Okay. The average rate of change.
Okay. Yeah.
So total change is, so we add these two. That's the total change.
Yeah.
And divided by, it changed over 2 years, right?
Yeah.
So total number of changes is 1 and 2. So divide by 2, then you can think that on average, it changed by about 64699. Of course, we have to put 3 more zeros. Yeah. That much changed per year, right? So that gives you B.
Yeah.
Or we can do, all right, the total change from there to there is 488,106 minus 358,708 over 2.
Yeah.
Because if you do that minus that, right? That plus that was 127,099. That's the change on the first year. This is the change on the second year. So 129,398, 129,398,000. This was the change over 2 years, and this is the change over 1 year.
Yeah.
So what I'm saying is that the second method is you can simply do that minus that, which is that minus that, and that's going to give you, so that's a 488,106 minus 358,708. That actually gives you that.
Yeah. Okay.
Because that's a total change over 2 years, right?
Yeah. Right. Right.
And of course, times by 3 zeros. And of course, that much change happened over 2 years, so divide by 2.
Yeah.
So you get the same answer.
Yeah.
Okay.
Right.
So you don't have to calculate a change from there to there, change from there to there. You can just do a change from there to there straight away and divide by 2.
Yeah.
So actually, number 2 is a better way. Instead of calculating this one and this one separately, you can calculate that straight away and then divide by 2.
Yeah.
23. Of the following, which program's ratio of its 2007 budget to 2010 budget is closest to human resources program ratio of its 2007 and 2010?
Yeah.
Right. So the ratio of human resources 2007 2010. So that's about 6:4, isn't it?
Yeah.
So you can just think. You don't have to do much calculation. That's just a 5.9. Now, when it says ratio of A to B, that's equal to A divided by B, okay?
Yeah. Yeah.
So it's 2007 divided by 2010. So that's equal to actually 4 divided by 5.9. So you don't have to take all of these numbers. That's a 5.9 million. This is 4 million. So the ratio is 4 over 5.9.
Okay.
It's about 0.7, 0.6768.
Mm-hmm.
So we need to figure out which one of these has similar ratio.
Yeah.
That's 2 to 3. That's 14 to 14. So cross that out, right?
Mm-hmm.
So you can just check. So this must be about 70% of that. Is that 70% of that?
No.
Is that 70% of that?
No.
So you just have to try,
Wait, I don't know about the last one.
Yeah, so let's try the first one. So just have to match, just approximate, save some time. So 373, 488. That's too high.
Yeah.
I just did that, divide by that, okay?
Sure.
So as long as they're, the digits match up, so you can see that that is no different from 373,904 divided by 488,106. It's pretty much the same thing. So this is 22164 divided by 3008. That's still a little bit high, right?
Yeah.
But so far this is the best one.
Mm-hmm.
I'm pretty sure this is almost 1. And then you go to, because it's 14 million, 14 million. So this is 1.4, you can divide 1.468 divided by 1.773. That's too high.
Yeah. Yeah.
So you go this one divided by that. 263 divided by 464. Oh, that's too low.
Yeah. So it's education.
I think it's education.
Yeah.
That was like 0.71. This is 6.8. So this must be the closest one, right?
Yeah.
So it's 2.164 divided by, you see, you can do it like that, 2.164 and 3.008,
Mm-hmm.
which is that. Or you can do 2,164, 3,008, doesn't matter, okay?
Yeah.
They're all the same ratio. So I think the answer is education.
Yeah.
Now let's move on to question 26. So we did 22, 23. And yeah, we did 24, 25, 26. Okay, so Katerina is a botanist studying the production of pears by two types of pear trees. She noticed that type A tree produced 20% more pears than type B. Based on Katerina's observation, if type A trees produced 144 pears, how many pears did tree B produce? So I'm going to leave that to you for a few minutes. So straight away, we can get rid of this one here.
Yeah.
Because it can't be more than 144.
Yeah.
So whatever so it produces 20% more pears than type B. So we can think about taking the 80% of 144.
Mm-hmm.
Could that be B? Or we can think about taking the whatever the B was, this one here,
Mm-hmm.
times that by 120%, and that could equal to 144, because that's 20%, you see?
Yeah.
So I think these are the main, two main ways of thinking about this problem.
Yeah.
So a lot of people get confused about this one. So do you think the first method is correct or the second method is correct? Or do they give you the same results?
They should give you the same result.
Okay, let's figure it out.
I
So
would assume.
144, they sound really similar, right? This is simply 80% of 144 because, this must be 20% more than this one. So
Yeah.
20% less of that one is this one.
Yeah.
Right? But interestingly, I think they give you different results. The 115.2,
Mm-hmm.
that's why they have this answer there. And if I do 144 divided by 1.2, gives you 120.
Okay.
So what this means is that so let's actually think about number 2 first.
Mm-hmm.
We assume that tree B produced 120 pairs.
Yeah.
Timesing by 1.2 is the same as taking the 120% of that, which is made up of 100%, which is the original number, plus 20% of the 120. So 20% of 120 is 24. So we are adding 120 plus 24, right?
Yeah.
That's basically what this is doing. That gives you 144, where the extra 24 extra pairs is the 20% of 120. Now, that's that. If we think about number one, we're saying that because A produces 20% more, the logic here is, well, 20%, 80% of 144, if you just simply take away 20%, would be B.
Yeah.
Right? But why do they give you different results? Is that confusing a little bit to you?
Yes.
Okay. So it all comes down to so here I'll give you something here. Let's think about this one. So 100 times by 0.8. So that's 80% of 100, right?
Yeah.
What should that give you?
At 80.
80, right? Does that mean 80 times by 120% give you 100?
Oh, no.
It doesn't. But it just feels like it will, right?
Right. Yeah. Okay.
So the reason is, when we are doing this calculation, we are basing the percentage on the original 100. So whatever the percentage here, so whether it's 80% or 20%, that's 80% or 20% of 100.
Yeah.
Now, when we are doing this one here, we are doing, whether you're doing 20% or 120%, we are actually doing 20% of what? 80.
Of the 80.
Of 80. So you see that 20% of 80 is actually 16. 20% of 100 is 20. Okay.
Okay.
You
Yeah.
see the difference?
Yeah.
So 20% of 100 is 20. 20% of 80 is 16. That's why there's a difference there.
Yeah.
So it really comes down to, should we base our percentage on, I want you to read this question again and tell me whether we should base our percentage on B or on A.
It should be on A.
Do you think so?
Oh, wait. It should be on the 144. Oh, wait. No. Right. Oh, I see.
Yeah, it's a little bit confusing, right?
Yeah. No, I get it. Yeah.
So you say the key idea is here. She noticed that type A produced 20% more pairs than B. So the English here is referring to, by grammar, it is actually 20% then B. So this 20% must be based on B.
Yep. Okay. Yeah. I see.
So do you think number 1 is correct or 2 is correct?
2.
The answer is 2. That's right. So it is whatever the B was, 120%, that is 144, not 80% of 144. Okay? Yeah.
Yep. Okay.
B. Okay, so that's the end of the test 1, section 4, first half of section 4.
Mm-hmm.
I think. Did we do that? Oh, hold on. We did that.
Yeah.
We did that as well. We did that. We did 20.
7.
We did that. 27 now.
Yep.
So it's not actually finished yet. Let's do 27 now. Okay, 27. All right. Square field measures 10 meters by 10 meters. 10 students each mark off a randomly selected region of the field. Each region is square and has side length of 1 meter. And no two regions overlap. The students count the earthworms contained in the soil to a depth of 5 centimeters beneath the ground surface in each region. The ground, yeah. The results are shown in the table below. So this is 10 meter by 10 meter, right?
Mm-hmm.
There's a field, which is 10 meter by 10 meter. There are 10 students, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this region, so students are going out to the field and then they're making some measurement on 10 different regions, like one there, like this, okay?
Yeah.
Each region is 1 meter by 1 meter, okay?
Mm-hmm.
So region A, so this could be region A, and none of them overlap, okay?
Yeah.
And they found this result. Which of the following is reasonable approximation of number of earthworms to a depth of 5 centimeters beneath the ground surface in the entire field? So all they did was, this is the 1 meter by 1 meter, for example. You don't need to pay attention to this 5 centimeter thing. They just go deep by 5 centimeters and just found the number of worms there, okay?
Yep.
Yeah. Yeah, destroying the worm's habitat completely. Now, just you can make a guess and get it right if you don't understand. Like,
Oh, it's 150.
It's 150 in each square meter, right?
Yeah. Oh wait,
in
entire.
the entire field.
So around 15. Or no, 1500.
1,500 or 15,000?
15.
450,000. Yeah.
1500.
Okay. So I want you to tell me this. If you
Oh wait, no. Wait.
If this is a 10 meter by 10 meter, okay,
Mm-hmm.
the area is how much?
100.
100 square meter, right?
Yeah.
This is a meter, so times this together, the meter square.
Yeah.
Now this one is 1 meter, right?
Yeah.
1 meter by 1 meter, so that's 1 meter square. How many of this can fit in here?
100.
So you can have 100 of those, right?
Yeah.
So you have a 100 of these little squares within the 10 meter by 10 meter. But in each square, there is approximately 150.
Mm-hmm.
So it's 150 times by 100.
Oh, okay. So
it'll be
15.
So if you times this one by 1, then you get this. If you times it by 10, then you get this. If you times it by another 0, then you get this one.
Yeah, right.
So 15,000. Make sense?
Yeah.
Okay, let's move on. Yeah, I think we did something similar to this one before. So in the system of inequalities, y is 2x plus 1 greater than that equal to y is greater than this one. Which quadrant contains no solution to this system? Okay. Can you draw y equals to, I'm going to actually draw this myself, 2x plus 1. So let's say this is 1 here, 2x, so gradient is positive, like that. So this is 1 here, and I can just plug in 0 here. 0 equals to 2x plus 1, and negative 1, 2x, so x is equal to negative half. So this one here is negative half. I found that by plugging 0 into y. Okay. And so that's my graph of this. I want you to graph this one.
Okay.
So I'll give the control over to you. You can do some calculation on a piece of paper. And you can draw. It'll go through -1, right?
Yeah. So, like that.
Yeah, I think that's very good. So it's got a less steep gradient, right?
Yes.
Still positive. So it goes like that and like that. So they expect to meet somewhere over here, right? So this is
Right.
-1. Can you figure out this value, please?
Sure.
If you want to go through
It's
some
2.
SAT verbal as well, you can just book an additional lesson.
Sure.
Okay.
Wait, what do you mean, like verbal?
Oh, the SAT English section.
Oh, right. Sure.
So this is quantitative section. The other one is verbal.
Yeah. Okay. So that's 2, I think.
That's 2. That's right. So there's 2 here. Have you tried any of the English questions?
I have not looked at the. Oh, actually, I had a brief skim over some questions, but I haven't gone in depth.
I'll probably give you some homework questions then.
Okay, sure.
Apart from this maths here.
Okay.
Yeah. At least if you get some external pressure from your tutor, then you might be putting more energy into it. Yeah, you can put more energy into it. Yeah. So give them as homework. Okay. So this -1, that's 2. That's very good. Now we are given greater like this, and this is greater than equal, isn't it? Greater, equal, greater, right? So now you can answer the question. You see how we shade regions based on like this one. If we have inequality, we have regions, right? Remember this stuff?
Oh yeah.
Yeah. So if it's an equal sign, then it's just a single line, right? But if it's greater than equal, then it is actually region above, isn't it?
Yeah.
All of the regions above this line, including this line as well.
Yeah.
Now, as for this one, this is greater, but not including. So it is actually not including this line, right? So that's why I put a dotted line there.
Yeah.
And it's region above, isn't it? Now, solution to this one and this one is a system of inequalities of these two is basically region that satisfies both of these inequalities.
Yeah.
So like a point over here, does that satisfy these two?
No.
No, it's only in the red, right?
Yeah.
What about point over here?
Yes.
Point over here?
No.
Here?
No.
Here?
Nope.
Here?
Yes.
Here?
Yes. Oh, no.
No,
sorry.
That's right. So let's have a look at quadrant 1. Quadrant 1 is, so if you divide this into 2 parts like this.
Does satisfy.
Sometimes, not all the time.
Right.
So here it does, but here it doesn't, right?
Yeah.
So some do, some don't.
Okay? Right.
Quadrant 2, which is over here.
Some as well.
Some as well, because it's here, not here, yes, right? So some as well. Number 3 is here.
Some as well.
Some as well. Quadrant 4.
Is none.
None of them, right?
Yeah.
So if the system blah, 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 which quadrant contains no solution?
The 4. Yeah, the last one.
2, 3, 4. It's actually 4, right?
Yeah.
Yeah. D is wrong because it says there are solutions in all 4. That's actually wrong, right? Because in the fourth quadrant, there is no solution.
Yeah.
Yeah, so there are solutions in 1, 2, 3, but not in 4. So that's the answer.
Right.
Okay. Not too bad, right? That question there.
Yep.
We're going to do 29. 29. So there's polynomial p of x. Do you know what polynomial is?
I think so.
Okay.
It's like,
so polynomial is something that looks like this. You have a, x to the power of n, b, x to the power of n minus 1, c, x to the power of n minus 2, etc., etc. So example is like if you have 2x to the power of 5, 3x to the power of 4, and then like x plus 1, that's polynomial.
Yeah.
That's our polynomial. So it has some x to the power of something.
Yeah.
With any number in front of it, okay?
Yes.
Now let me ask you this. Is this polynomial 2x to the power of half plus 1?
No.
This one is, but this one isn't.
Yeah.
So you're right. What about this one? Half x. Is that polynomial?
No.
Yes, it is.
Oh.
This is a power of 1 here, right?
Oh, right. Okay.
What about this one? Square root of 2 x to the power of 5 plus x to the power of 2 minus 4.
Yes.
It is a polynomial. So the only thing that really matters is those exponents.
Yep.
Try this one. Is this a polynomial?
Yes.
No.
Oh.
Because of that. That's negative.
Wait, what? I don't get that. Sorry.
If it's a negative power, it's not a polynomial.
Oh, okay.
Okay. What about this one? Is that polynomial or not?
No.
No. Why?
Because of the x squared it's divided by, sorry, it's 1 divided by x squared rather than the whole thing being
yeah, you noticed that. Do you know that this one is the same as this one here? Did you know that x to the power of negative power is the same as 1 over x to the power of the positive power?
Oh, okay.
Yeah.
Oh, right.
This is very, very important. If you have like x to the power of, so whenever you have negative power, remember this, you can send it to, you can change the position. Change the position and then change the sign, okay?
Mm-hmm. Yeah, okay. I think I've seen that before.
Yeah, if you have like a 1 over x to the power of negative 4, you see how that's negative?
Yeah.
So you can change the position and make it to the top, and it becomes x to the power of 4.
Yeah.
If you have like 2 over 3 to the power of negative 3, this can be changed to positive power. This one can go down, this one can go up, like that.
Mm-hmm.
The same thing. And there's 27 over 8.
Right.
Anyway, so these are polynomials.
Yeah.
These are not, the crosses, these are not. Anyway, question 29 says there's a polynomial. And when you plug in 3, that's what it means. When you plug in 3 into the x, the whole thing is -2.
Sure.
Which one must be true about the p of x? So this is going to take a bit of time for me to explain,
Okay.
but I'll just tell you something. Maybe I should do it now. Okay. If I can just summarize this, it goes like this. If p of 2 equals to 0, then x minus 2 is a factor.
Okay.
If p of 2 equals to 3, then 3 is the remainder when p of x is divided by x minus 2. Of course, in this case, this is the remainder, but remainder is 0.
Mm-hmm.
If
Yeah.
remainder is 0, then of course x minus 2 is a factor. Factor is something that divides exactly, right?
Yeah. Okay.
So that's why this is known as factor theorem.
Mm-hmm.
That's factor theorem. So if you plug it in and you get 0, that means this is factor. If
Yeah.
you plug it in and it gives you something other than 0, then whatever that value is, that's the remainder when divided by x minus 2. All right. So of course, I did not go through the derivation, the proof of this, and I haven't explained what long division. Have you ever seen long division?
A while ago, yeah.
Yeah, I have not done any of that stuff.
Mm-hmm.
But I'm going to just ask you to answer this question based on this this formula here, based on these two. So what I got is a p of 3 is -2. Okay.
Right. So
Based on what I wrote there, what's the answer?
C.
Is x plus 2 a factor? Okay. Did we get 0 here?
No.
So I don't think it's the first one. I think it's the second one.
Oh, so
This is p of 2 equals 3, but I've got p of 3 equals -2 here.
okay. So -2 is the remainder.
-2 is the remainder when the polynomial is divided by
3.
x minus 3.
Oh, right. X minus 3.
You see, when there's 2 there, okay.
Yeah.
It's in color. 2 there. It's 2 there.
Mm-hmm.
Remainder is 3. 3. Okay.
Yeah.
So the answer is D here.
Okay. Right.
I'll go through some more on the polynomial stuff if it shows up again. All right.
Okay.
It will.
Yeah.
But for now, just need to know these rules.
Okay. Sure.
Now we're going to do 30. Question 30. Okay, so this is about another quadratic. Not sure if we can do that with the limited space, but let's give it a go. Okay. So we've got this parabola, and the equation of the parabola is given by this.
Sure.
And it's 5 there, -3 there. Which of the following is the equivalent form of the equation of the following of the graph in the xy plane above? from which the coordinates of the vertex A can be identified as constants in the equation. Okay.
Yeah. Mm-hmm.
Well, what's the vertex here? Can you tell me the vertex?
It's like a minus 16-ish.
It's yeah, minus 16 there for the y value, but x value is 1, right?
Oh, right, 1. Yeah, right.
So can you fill in this blank there? I'll give the control over to you. Just fill in the numbers there. The coordinates of that point.
I just think it's probably near minus 16. I don't know if that's...
Yep, that's all good.
Right.
Now, which one of these equations, I'll just leave this one to you, which of the following?
Sure. Is it D?
That's right. That's the correct answer.
Right.
You can circle that one.
Oh, right. Okay, sorry, it didn't work.
Yeah. Okay, so that's the correct answer.
Right.
Obviously, to go from here to this form, so I think this is you see the x-intercepts are -3 and 5, right?
Yeah.
So do you think when you factorize this, do you think you get A or B? One of them is actually correct.
Is it A?
It is A, that's right, because it's -3 must be +3, right?
Yeah.
+5 must be -5.
Right.
You understand the reason, true? Because
Yeah.
when x is equal to -3, y must be 0. So this must be 0 when x is -3. But when x is -3, you +3 with it, then it becomes 0, true?
Yeah.
But if you plug -3 into x here, and then you -3, then you get -6, which is not 0.
Right. Yeah.
That's why this is not correct. And when you factorize this one, you need to find, let's say you're not given the graph, but you need to figure out factorization version of this. Then you need to figure out two numbers that multiply to give -15 and add to give -2.
Okay.
So 5 times 3 is sort of 15, and then 5 plus 3 can sort of give you 2, right?
Right. If it's negative, yeah.
So it must be -5, right? Plus 3, then -2, right? And -5 times by 3 is -15.
Right.
So the answer is x minus 5, and then x plus 3.
Yeah.
That's the factorization of the graph of that function. And you get this, which gives you 5, +5, and -3.
Yeah. Right. Okay.
So this is not a wrong version of, this is exactly the same graph as this one, but that's not what we're looking for here. We're looking for the vertex form.
Right.
And the vertex form is this one.
Yeah.
So there are three forms: y equals to ax squared plus bx plus c. That's the general form. General form. And the factorized version is a bracket x minus alpha, x minus beta. That's the factorized form, where alpha is like -3, beta is 5. So if the x-intercept is -3, then you get x minus -3. That's why you get +3. Okay.
Right.
This is that's -3 there. Okay, +3 there. So there's a reason why there's a negative sign in the formula. See?
Yeah.
And then because beta is 5, you can see, and there's a negative sign there in front of it, so it's -5.
Right.
Okay. And then a is just a constant. You have to figure it out. I'll explain more about that later.
Okay.
So if you figure it out, it's equal to 1. So that's the x-intercept form. Now, the vertex form is given by A. So what's A? A is, by the way, You see how this is x squared with a 1 in front of it?
Yeah.
That's the a value.
Right.
Sometimes it's not 1, you know?
Mm-hmm.
And then you get the vertex form is x minus h squared plus k.
Yeah. Okay.
So obviously, because this one is 1x squared, that's why this a is 1. And then you see the vertex is 1, negative 16, right?
Yeah.
So because this is 1 here, it's negative 1 here. H is the x value of the vertex.
Yeah.
Square. And this is plus k, true?
Right.
K is the y value of the vertex.
Yeah.
That's negative 16. So this turns into positive negative 16, so there's negative 16 there.
Yeah. Right.
That's why you get this one here.
Right. Okay. Mm-hmm.
I want you to try this one then. Find the equation for this is 3, negative 4, and let's say this one is 1. Okay.
Mm-hmm.
I want you to find the equation of this in this form. You need to figure out A, H, and K.
Okay.
So I'll leave that as homework.
Mm-hmm.
Once you're done, just send a photo to me
Okay.
on
Sure.
Facebook Messenger, all right? And we'll call it a day here.
Okay. Is there something I should do for the English thing, or you'll just send?
I'll send you the homework for English.
Okay. Sure. Okay.
Maybe, do you have this test 1? Did I send it to you?
No.
Okay, I'll send it to you now.
All right. Sure.
So for English test, you can maybe try section 1, all of section 1 maybe, over the weekend. It's just as much as maybe it's too much. I don't know, just it's up to 52.
Sure.
Just do as many questions as possible and get it checked by me. All right.
Yep. No worries.
All you need to do is just send me answers. Like just
Okay.
like type 1 and then like if the answer is A.
Yeah.
Like this, you know, 1 A, 2 B, etc.
Yeah. Sure. No worries.
Okay, we'll call it a day here.
All right. Thank you.